Hi, my name is ISYRAF bin JAAFRI. My matrix number is 200673.
Okay, my name is HAFIZ bin FAIRUZ and my matrix number is 200475.
Hi guys, my name is YING and I am a Mahasiswi UPM. My matrix number is 203898.
Okay, what is dispersion of light? Dispersion of light is white light pass through a glass prism and it splits into 7 spectrum of colors in order red, orange, yellow, green, blue, indigo and violet. The white light is passed through the glass prism and is termed as dispersion. The simplest way to explain dispersion is through dispersion in the prism. So, this show dispersion of light can easily found in our real life and very easy to understand the concept because it using the color of the rainbow. As we know, rainbow has 7 colors and the 7 colors are the spectrum of the light for dispersion of light. Another example of the dispersion of light in our real life, for the firstly, as we know, is the rainbow. The secondly is about the CD. Why dispersion of light is important in our real life? As we know, dispersion of light concept is used for designing the optical equipment such as cameras, optical microscope, telescope, binoculars, and something using the lens. The lens system not designed to focus for different color, but by using this dispersion of light concept, it will focusing on something by the 7 type of colors. So the image will be so clearly when we use the equipment. Reflection of light at the glass will travel from the glass to the air with the 7 colors that we can see. The different colors of spectrum of light have the different length wave. For example, the violet have band the most and it have the shortest wavelength, while for the red it have band at the least and have the longest wavelength. So because of dispersion of light can show that every spectrum of light have different wavelength and different bands. How dispersion of light is happen? The dispersion of light happen when white light travel from another medium to another medium. For firstly, white light travel from the air to the glass. When it hit the glass, it will refract in the glass. So this way will produce the light through the prism and illustrated the diagram of the colors. So, what is objective of this experiment? The first objective of dispersion of light is how the light refracted through the glass prism. When light travels from one medium to another medium, it will cause a result between it bends or is refracted in the glass prism. When the light passes through the prism, it will give different colors in the spectrum of light. So this shows the light have different wavelengths. The violet bends the most and having the shortest wavelength, while red bends the least and having the longest wavelength. And next, the white light is passed through a glass prism and refracted not once but twice. And in this experiment, we can see the white light is travel from air into the glass and refracted in the glass, and lastly it will disperse from glass into the air.
So now I will show you a demonstration of how dispersion of light works.
Instead of using a prism, we only use a small mirror and then a torchlight and a few water.
Okay, so the first step is we fill any container or basin with water. Next, the second step is put the mirror into the container at an angle, but make sure we do this in a dark room because it will be easier to see the light. The third step is position the glasses so that the light shines directly at the mirror. We have to shift the mirror to find the right angle. So this is the result that we got. If you look carefully, there is the rainbow on the water, which is due to the dispersion of light. Right? Beautiful, right? But how does this happen? As we know, when light passes from one medium to another medium of a different density, such as air to water, the light bends. This is known as refraction of light. Therefore, white light from the torchlight is split up after passing from air to water, and the individual colors become visible. This dispersion of light allows us to see a spectrum of colors that form a rainbow.
Now let us see how the operation of dispersion works. Here we can see this is a prism. And we can imagine this prism as the water dropper of the experiment our friend carried out just now. This is the surface of the water dropper, and we imagine that surface as a prism. And we can draw a normal at the surface, and this normal is where the refraction carried out. And we imagine this as a light source, which is what we used just now, as the light source we use is a white light. As we all know, white light consists of a millions of a color. That is this. We can see the white light as a beam of color that is red, from red to violet, and violet has a higher frequency and a lower lambda. And for opposite, red light has a higher lambda and a lower frequency. And as we all know, white light travel at a constant speed, that in vacuum, that is c equals to 3.0 times 10 to the power of 8 meter per second. But different color travel in different speed in a medium. In this case, the violet travel slower than red color in the prism. And from the index equation, we know that the index of refractive equals to the speed of light travel in vacuum and divided by the speed of light in medium. And since the violet travel slower in a medium, so we know that the refractive index of a violet is higher compared with the refractive index of red color. And the higher refractive index means the violet light will bend more if the refraction happen in if the refraction happen. That will mean this is the violet light because the refractive index of violet light is higher. Then the violet light will bend more compared to the red light. And here is another refractive occur. And as a result, we can see the spectrum of color light. And this is the phenomena of how rainbow light wave form.
So, as a conclusion, we can conclude that dispersion of light can be defined as the splitting of white light when it passes through a glass prism into its constituent spectrum of colors such as violet, indigo, blue, green, yellow, orange and red. Dispersion figuratively means distribution, and hence that's exactly what is happening during our experiment. So, other than that, we can conclude that the experiment for dispersion of light is easy to make, since we only have to show how the rainbow happened, which also due to the dispersion of light. So I think that's all from us. Thank you.